Hi everyone, thanks for watching this video. I'm here to talk about a way to categorize APIs in layers and give name to the layers such as experience, process, system, and more names. So before I move to the API layers, I like to mention that in last 2 decades there are three architecture styles, monolith, SOA, and microservices that have dominated the most of the architecture of software. Um, so like 2 decades back, most of the applications were monolith applications in which if you have a function and it invokes another function, in most cases, both of these functions were part of the same application, and there was very few remote calls. And then service-oriented architecture came, in which we built services, and these services were exposing standard interfaces, which can so that service can be consumed by code written in any language, and these are reusable services. The purpose was more to solve the integration problems. And last 10 years, microservices have dominated and they are widely accepted now everywhere. So in microservices, we break a complex business problem into smaller services, and each service owns its data and business logic. And these services expose standard interface API. Um, this is the difference that microservices are exposing now APIs, whereas service-oriented architecture, the interface was SOAP. When I started working in large enterprises, so like 15 years back, and this was a common architecture and structure of the organizations. So organizations had kind of teams based on a skill set like UI team, backend team, and database team. And these teams were each individual layer team was then again distributed into multiple applications. So if so like actually if I was working in a bank and there was a application for retail banking, and some members will come from UI team, some backend team, and some members from database team, and they will form one team that will look after the development and support of this retail banking application. In similar, there will be a team for cards application. What it led to was a siloed enterprise in which teams were unaware of what was going on in other applications. And also, if there is a feature in which we want to integrate data across two applications, then it was difficult. Um, so then service-oriented architecture came, which the purpose was to solve this kind of problem. And I was working in an organization where we built a entire middleware, a middle layer, which integrates with all backend systems. So these backend systems were legacy systems and big systems, monolith systems, which exposed some interfaces uh, with complex objects. And most of these systems had their own proprietary formats, so like EDI, CSV, XML. Our middle layer used to hide this complexity and exposed one common standard interface, SOAP interface. So any front-end application that needs data from the back-end application consumes our web service, which is written in SOAP, and gets data in XML format. And our service it can bring that data from multiple downstream system or one system. The front-end service is not bothered about that. The whole purpose was to create some services that can be reused in future. So one of the value proposition of service-oriented architecture was cost saving, because we can reuse them as many times as possible, and these services make sense to business also. So everything was good. But the problem we faced with SOA layer was, number one, that it became very fat layer. It was expensive to maintain because of it was built using IBM products, and the SOAP interface was very verbose. Um, there were, at the same time, there were new front-end applications, mostly mobile applications, which were not very comfortable with the XML interfaces. So, and they were looking for an alternative, which was an API, which was using API uses JSON as request response model, and APIs use standard HTTP methods. Whereas in SOAP, it's a developer's choice; they can write any method name. So our organization decided to move to API, and initially what we did was we created an operational data store in which data was copied from multiple existing systems, and this we wrote a layer of API over this operational data store. Operational data store was MongoDB and NoSQL, and we created a lot of kind of a aggregated composite data models inside this operational data store, and we wrote APIs to read data from this ODS store. Now, initially APIs were read-only, but later they became read-write, and slowly APIs started replacing SOAP web services. It looks good, but at the end we were moving towards the same problem, because now this API layer is going to be a very fat layer, um, and the data is very huge in operational data store because the enterprise is like 30-40 years old. And we felt a need that we need some kind of a management of APIs, because we also realized that not all APIs are same. The governance can be different for each API. Some APIs are external, some are internal, some perform CRUD operations, some have complicated business logic. So uh, one of the architecture pattern that we adopted was inspired by MuleSoft, and MuleSoft gave this pattern in which they came of 3 layers of API and 3 naming conventions. Now this architecture came like 5, 6, or 7, 8 years back, and this came according to the requirements of that time, and mainly focusing on incumbent big enterprises which had a lot of legacy systems. So they mentioned that we should write APIs in 3 layers. There should be a central IT team which is writing the system APIs, and system APIs are designed to unlock difficult to access and core data such as customer account products. And these system APIs hide the complexity of the core systems from users. And these system APIs can interact with legacy systems, monoliths, or relational, non-relational databases. Then there is a layer of process APIs, and process APIs define and share common processes such as aggregating account balances, accessing creditworthiness, creating a new customer. So they manipulate and aggregate data from system APIs. They also implement complicated business logic. And then at the top layer, we have experience APIs, which reconfigure data according to the requirements of the audience. An audience are front-end channels such as like online application, mobile application, and more important is that experience APIs also manage authentication, authorization, and auditing. And experience APIs are considered as external facing APIs. So the governance for experience API is different from process APIs and system APIs, and the consumers are also different. Now, actually, experience APIs also follow back and forth front end pattern. So, for example, we have an online banking system, an online and a mobile banking system. So both online and mobile banking system present account summary, but they both will be presenting in different way because the screen size is different. So we can have a separate experience API for mobile banking and a separate experience API for online banking. Also, the authentication is different. So experience API of mobile banking deals with how mobile applications authenticate. In similar, experience API for online banking deals authentication, authorization, and auditing for the online systems. Now, both these experience APIs can actually use the same downstream process APIs. This is an example of three layers of API in a bank. So we have a data store. Assume it's a big data store with multiple schemas like customer, accounts, transactions. And we write three system APIs. Now, these system APIs just perform CRUD operations, customer API over customer data store, in similar accounts and transactions on accounts and transactions data store, respectively. Now, we write some process APIs like get customer accounts API or get transaction summary API. Get customer accounts API, bring all the accounts of the customer, prepares a summary, and get transaction summary API goes to all the accounts of the customer, goes through all the transactions done in last, for example, 1 day, and prepares a transaction summary. Uh, and we have an experience API, homepage API. So when the customer log in into mobile app, on the homepage they see a summary which includes a summary of customer accounts and a summary of all the transactions done by customer in last 1 day. So get home API is experience API, customer accounts API, and transaction summary API are process API. So this pattern was followed rigorously in the organization, and slowly it became a standard. And the problem came was that now for every business use case, every feature, we were writing three layers of API. Sometimes it felt extraneous, a lot of work because sometimes experience API is just a pass-through API. And sometimes like actually you are just performing a get, and mobile application needs some transaction details. So you write three layers of API, experience API, process API, system API. It felt like there is no consideration done over functional and technical cohesiveness of the features. So uh, every API written independently, and every new use case we're writing new set of APIs. We're just creating thousands of APIs. What was missing in this whole thing was that from the very beginning we didn't did any kind of domain-driven design. So domain-driven design is a pattern, a design pattern. It's very popular along with microservices because it helps us analyze a problem domain, break that problem domain into subdomains, and create bounded context around subdomains. Implement each subdomain as an independent microservice, and microservice exposes a standard API. Now this microservice performs all kind of business logic, all kind of CRUD operations for the data it owns. And it's not like actually for every API we have an independent microservice. Instead, microservice there is a consideration done for functional cohesiveness. So for example, we can create a microservice customer, and it manages everything related to customers, such as customer address, customer contact, customer KYC, create customer, update customer, and this way it becomes manageable. So if I start a new project or I'm working in a greenfield system, then what I do is that I know on the top there will be channels like mobile, online, external consumers, and at the bottom we have data stores. And these data stores can be SQL, NoSQL, including data warehouse. And in the middle we have this set of microservices. And these microservices are designed using domain-driven design. And a big complex problem is broken down into smaller subdomains. One subdomain has an aggregate and related entities. So it has one core entity. So for example, account bounded context has account as core entity, customer has customer as a core entity, and there are some related entities. Since one microservice can combine the functionality of both process API and system APIs because it owns its database. So it will expose the CRUD operations, and it will also can implement, any kind of business logic. So customer microservice has all the business logic of customer. Now, can So if we go with this approach, then we will reduce the number of APIs, especially in from the process API layer and system API layer. And still, there will be a use case where we need to implement a logic that goes across bounded contexts. So that involves data from two bounded contexts, such for example, customer transactions or account transactions. So then in that case, we can use the experience API. So it seems like we can go with something like this, that we first do a domain-driven design. We come up with subdomains. We implement them as independent microservices or independent bounded context. Each bounded context owning its data store. And these bounded context microservices are exposing APIs which can be consumed by front-end channels, and these microservices can be event driven, so they can communicate with each other, um, either using direct API call, or they can use events or messages to communicate with each other. And the requirement when in which front-end channel needs data from across domain, from multiple domains, then Experience API does this kind of aggregation. So here in this example, we have implemented a new customer onboarding journey that has few screens. So customer lands on the home page of mobile banking application, and checks for what all products he or she is eligible. Then goes to the eligibility screen, and eligibility check is done, and based on that, a offer is presented. So it's like not onboarding, but it's a new account opening journey. So we have written 4 experience APIs, one experience API corresponding to each screen. So now actually I can talk later in some videos how to design experience APIs, how to decide number of experience APIs. But for now, for simplicity, we can assume that every screen has its own dedicated experience API. And this experience API brings all the data needed for that screen, and it can communicate with multiple downstream systems. So we have removed process API and system API and replaced them with domain services. Still, in the enterprise now, in the enterprise in which I was working, we did this. We started doing this. For any kind of new development, we started doing domain-driven design and implemented services. Um, Instead of 2 layers of process API and system API, just one microservice. So there was a kind of a mix. There were experience APIs also. There was some process API, system APIs, which we wrote in few years. And then there are new domain services. And there are still some system APIs which are interacting with legacy systems. So, and one difference, or say one more difference between Experience API and other downstream APIs is that Experience APIs maintain a distributed cache, since because they maintain the customer session, whereas the downstream APIs are totally stateless. So Experience APIs are also stateless, but they maintain their state with the help of distributed cache. Because it might be possible that your customer login into, for example, mobile banking app, and we have already loaded the customer account summary uh, when customer was on the home page of the mobile app. Then we can store this information in the cache, and it can be reused by other experience APIs while customer is browsing on other screens in the mobile application. And recently, actually, I was working in some other project where they were calling not experience API. They were not using this term. Instead, they were using term as edge services. And in another project, they used to call it presentation APIs. And the domain services, they used to call domain APIs. So if we use all these terms, then we have some experience, presentation, or edge services, which are at the edge layer. In the backend, we can have either process APIs or system APIs or domain APIs. Um, and then next important question, and I already mentioned about is that should multiple channels have the same experience API? And this is a backend for front-end pattern. In this pattern, we suggest that different channels have different requirements in terms of request response format, authentication, authorization, auditing, So we should have a separate backend for each front-end channel. So for example, separate backend for mobile app and a separate backend for desktop app, separate backend for online, separate backend for external clients. So for each front-end consumer channel, we should have a separate backend. So this means that for a mobile app, an online app, we have a different set of experience APIs, and these experience APIs can invoke the same downstream domain APIs and system APIs. So one more point is that we still have layers. And important is to note that layers will still be there, but we have a relaxed layering architecture in which there is no foundation that experience API will always call process API and process API will always call system API. Instead, experience API can directly invoke the system API. So relaxed layering architecture. And so actually, instead of each experience API managing the cross-cutting concern like authentication, authorization, auditing, we can have a perimeter layer, perimeter. And this perimeter can be a firewall. We don't know actually, like the responsibilities of this perimeter can vary, but in general, there will always be some perimeter, some boundary behind which experience API will be sitting. So um, what during this implementation, what we realized that there is happening a lot of duplication. So we adopted backend for front-end pattern, but we came to see that a lot of code is getting duplicated. Many times the requirements of mobile application and online application was same, but since because we adopted this pattern, backend for front ends, we were writing duplicate code. And I saw this example from eBay where they wrote experience services. They call it experience service. So experience service is implemented once, and it does many things like orchestration across multiple downstream domain services. And this experience service is common. So both mobile and online application can invoke this experience service. So my personal belief is that if there is some very highly reusable, complicated architecture, or sorry, complicated thing, like we used to do in the case of service-oriented architecture, we can still write experience service that can be reused across both mobile and online. And especially in cases where they don't have any special requirements, the requirements of both are the same. They need the same data. So we can have experience services. So, architecture can be modified that has experience APIs, domain APIs, system APIs. Now, system APIs are totally optional because you might not have any legacy system. Um, and we have experience services. So we actually, all my purpose is here is that we still are naming, we are still giving layers, but we are open and like regarding in terms of communication pattern. So next thing, actually, many places, in most of the places, we are using API gateways. Now, API gateways are like perimeter, but gateways have matured a lot, and now they can do many things. They can handle authentication, authorization. They can handle request logging, request response formatting. So they can do many things for which we are writing experience API. And some API gateways can, some cannot, can handle the n+1 problem wherein they can combine they can do the orchestration. But many API gateways are not suitable for doing the orchestration, but they can do rest of the things of the experience API. So if we are using API gateway and we don't use, my recommendation is that we shouldn't use one common API gateway across all front-end channels. So if we create a separate API gateway for mobile, separate API gateway for online, so API gateway is kind of a layer of an experience API. So we can have mobile API gateway and we have online API gateway. Now, mobile API gateway reduces a lot of work of experience API. So mobile API gateway, from mobile API gateway, we can directly come the domain APIs. If there is no such requirement of request response, complex reformatting, or no such requirement of implementing some logic in the Experience API, or if there is no requirement of doing some orchestration in the Experience API, then there is no need to write an Experience API. API gateway can directly invoke the domain. And since we have separate API gateway for mobile and online, so it's also following the backend for front end pattern. We reduce a lot of code written in Experience APIs with this. And we have layers in this architecture, but still they are relaxed. So um, lastly, I would like to mention that the names are not, we should not be actually bound to these names like experience, process, and system APIs. In another project in which I was working, they used to call data access API, function API, and presentation API. So it really depends on the organization, what naming convention they prefer. But within an organization, we should have a common language for the API layers. We should logically refer APIs according to the layer they belong. We should have security, ownership, dependencies, governance, things according to the layer. And at the same time, keep layers relaxed. That's it. And thank you very much for watching this video. Thanks. Bye.